today we will find this limit, that limit n tends to infinity 1 plus x by n to the power n. So what is the limit? Okay, so we see that in power we have n, and the limit is also n. So when there is power, so we should take logarithm on both sides. Okay, so let's see what happens. So we take fx, or let's say fn is equals to what is given. Okay, so we take fn as 1 plus x by n whole to the power n. Okay, so since this is a function of n, we don't consider x actually right now. So now take log on both sides. So then what is log f? In got this? So n log 1 plus x by n. All right, now we take limit of this function. So let's see what happens. All right, so if I now take the limit of this log f, n tends to infinity, of course. So this means got this? So that's what we get, limit n log 1 plus x by n as n tends to infinity. So of course our main target is to apply L'Hospital rule. So what we do, we write this. Okay, so if I write like this, then what happens, that 1 by n that tends to 0, of course, and log of 1 plus x by n, if n tends to 0, this means x by n tends to 0, so log 1, that is 0, so that is 0 by 0 form. Okay, so that is 0 by 0 form. So now we should just direct derivative with respect to n. We know that we cannot really derivative because this is n is actually a discrete function, because it's a natural number, but still we can do it because there are some rules that says we can do it, because this is limit, and limit is actually not discrete, limit is actually continuous in certain sense. So we can derivative with respect to n. Let's see what happens. First of all, on the upper side and lower side, so for upper side we have this, so log of that, and then derivative of the inner side, which is 0, then plus like this. So let's see this. Okay, then for 1 by n we have minus 1 by n square. All right, so that's what we get. Okay, all right, so now if I just simply do some tricks over here, we see that this and this actually vanishes. We have only x over there, and for this limit it basically goes like this. That is basically x. All right, so x by 1 plus 0, which is really x. Okay, because x by n as n tends to infinity, that becomes 0, so 1 plus 0, there is nothing left, and we have 0 plus x actually, so, and 1 by n square cancel, so the limit is x, so this limit is actually x. Okay, so whatever written inside of instead of x, that should be the value of this entire limit, and that's what we have in this format of this kind of functions. Okay, x, okay, that is not x, excuse me. So now since we took it as log of this function, that is not x, so the limit of this logarithm of f is in x. Now we know that logarithm function is continuous, so from that point of view, if I take exponential on both sides, then what would happen, that limit of f should be e to the power x. Okay, so means this limit is e to the power x. Okay, so that is the answer. And we know that if x is actually 1, then it becomes e to the power 1, which is e, which is actually the standard limit of this kind of format of this. Okay, so as n tends to infinity, so this is, we know that is e. So that is how it is. Okay, so I hope you really like this video, and you like this kind of video. And this is just a demonstration that how things really work. And of course we have to use that last pedal is very important for any kind of limit form, because it is almost everywhere. Thanks for watching.